So good morning, everyone. This morning we're going to be taking a look at this PhET virtual lab over pH scale. You can find that if you go to classwork. It's this one right here, pH scale PhET investigation. Now, whether you choose to print it out or whether you choose to just type it in, that is really up to you. Do whatever's easiest for you. I printed a copy out myself so that I could doodle on it because that's just going to go a little bit faster for me as far as showing you the stuff you need to write down. All of this paper is going to go with the PhET simulation pH scale. So I'm going to start. Let me get my webcam started up here real quick. I'm going to start reading directions on here. It talks about just some intro on the pH scale. Says you're probably familiar with the sour taste of lemon juice, slippery feel of basic soap. There we go. View option. Let's go full screen. These are characteristics that we associate with acids and bases. It re-mentions talking about defining an acid as a proton donor and a base as a proton acceptor, which is the Bronsted-Lowry definition. And then if you had tuned into the live lab last Friday or watched the video, they talked about some of the differences between weak bases and strong bases and how it's not so much necessarily the base itself, or like the concentration of the base, it has more to do with how well that base ionizes. In other words, when you put it in water, how well does it give off hydrogen ions, or how well does it grab them? And the more that it ionizes in water tells you how strong of an acid or how strong of a base it is. The video that I talked yesterday talked a little bit about the pH scale and how the pH scale is a logarithmic scale based on concentration. So if you missed that, you can go back and watch that. If we get to any of the math involved in that, then I'll just kind of do a very quick recap, but for more information, you really do need to watch that other video. And so I'm going to move on to page 2 because page 1 is just introduction. So for our procedure, they want us to go into phet.colorado.edu, pull up the pH scale sim. We're going to choose the micro tab. So I'm going to jump over to this and I'm going to click micro. All right. And they give us all kinds of fun stuff to play with. So let's talk about some things that we're seeing on this screen. We've got a gauge on the left-hand side, which gives us concentration of hydronium, concentration of hydroxide, and just concentration of regular old water molecules. And so based on this, if one of the definitions of an acid is that it has a higher hydronium concentration than hydroxide, then we can determine based on this that this right here is an acid. And if you look here, we've got a pH meter. pH is saying that we've got a pH of 5.8. And if you recall, acids fall between 0 and 7, so this is definitely in that range. It's closer to 7, which means that it's not a really, really strong acid, but it's definitely more acidic than water. It's maybe somewhere between 10 and 100 times more acidic than water is. You've got a choice of different substances up here, and it gives you all of their starting pHs. It tells you in this simulation, we're going to be working with battery acid. So I'm going to come down here to battery acid, which has a pH of 1.0. It says to add battery acid and then use the bottom faucet to drain the tank until 0.1 liter remains. So I'm going to use this knob down here until I'm down to 0.1 liter of this stuff. You got to be really careful on this lab because It's really sensitive, and if you miss, then you might have to end up starting things back over. So here I am at 0.1 liter. First question there is record the pH of the solution. So looking at my pH meter, my pH is 1.00. Back over on my paper, where it says to record the pH of the solution, I'm going to write 1.00. Okay. Number 2, it says how many moles of hydronium ions are present in each liter of solution. So I'm going to come over here and we're going to look back at our thing. It says recall how pH relates to the exponent of the concentration of hydronium ions, and it wants it in scientific notation in decimal form. So my concentration in moles per liter on this is 1 times 10 to the negative 1. Okay, there's hydronium concentration. So I'm going to come back over to my paper. I'm going to say that it's equal to 1 times 10 to the negative 1. It also wants it in decimal form. So if I expand this out to decimal form, that means that I am going to be bumping the decimal to the left 1. So 0.1 moles per liter. Okay, or yeah, so all of that is our molar concentration. Okay, it wants to know how many moles of H3O ions. Now hold on, I might have missed something. Let's read here. It says are present in each liter of solution. Okay, so that's correct. How many moles are present in 0.1 liters of the solution? So if I've only got 1/10 of a liter, then my answer should be 1/10 of what I've got up here, right? So 1/10 of that would be just dividing that by 10 again. So I'm going to have 0.01 moles. Okay. If I'm going too fast for anybody, or if you've got a question, then type one up in the chat and I will try and answer it. Are we good so far? Next part is where it starts getting fun. What we're going to be doing is something called a serial dilution of this acid, meaning that we're going to be diluting it by a certain factor over and over again, and we're going to be checking to see what effect that has on. In our directions, it says to add water until there's 1 liter of solution in the tub. So we're going to add water from our water spigot here to bring our volume up to 1 liter. Doobie-doobie-doo. And as I do that, notice a few things about our chicken soup. Notice that our pH is increasing, meaning it's becoming less acidic. The color, it was kind of a dark yellow to start with. The color is getting more faint. If you look over here at your concentrations of things, there are some slight changes going on there. Okay, I'm getting close. So I'm going to slow. This is definitely a little bit easier to do with a mouse because you get a little more control over stuff. So I've diluted it down to 1 liter. Okay, so let's take a look at the questions it's asking now. It says, compared to the H2O in the battery acid, or I'm sorry, the H3O in the water is negligible. So we can consider the amount of H3O in the diluted solution to be unchanged by the added water. If you look, that really hasn't changed very much. This didn't move very much is what they're saying. Question 4 says, since the amount of hydronium is essentially unchanged, how many moles of H3O ions are present in the liter of diluted solution? Well, we had 0.01 moles a minute ago. That hasn't changed, so we still have 0.01 moles. All we've done is we've diluted it. All we've done is added more water to make the concentration compared to the entire thing lower. Okay, what's the new concentration of H3O ions in moles per liter? Let's go take a look at our lab and see what that says. It says that our new concentration moles per liter is 0.1 times 10 to the negative 2. So I'm going to record that here on my paper. 1.1 times 10 to the negative 2. It doesn't say to do this, but I'm going to go ahead and do this just because. I'm going to go ahead and change it to decimal form. So if it's times 10 to the negative 2, that means that I'm moving the decimal twice, so it's going to be 0.011 moles per liter, which is almost exactly what we have right here. This 1/100th of a mole, we're talking very, very, very tiny amount. And that happens, remember, because water does that whole self-ionizing thing where sometimes water molecules can spontaneously, some of them will give their hydrogens over to some other ones, and so it automatically makes some hydronium and hydroxide. So that explains that very, very slight difference in the numbers, but there's not very much difference. My next question is, what is the pH of the new diluted solution? Well, if I look here at my pH meter, it says it's 1.98, so I'm going to go ahead and record that. Now I'm going to keep in mind, though, since I know that pH is related to inverse logarithm of concentration, here it's times 10 to the negative 2. This number is awfully close to the whole number 2. Okay, so I'm just going to think that in the back of my head. Okay, well, I decreased the concentration by a factor of 10, and it changed my pH one whole step from 1 down to 2. Okay, before we move on, does anybody have any questions? Everybody seems to be doing okay. Y'all can throw me a thumbs up or something if you're feeling it. Okay. Let me expand my participant list here real quick so I can see everybody. All right, Big Dog is giving me the take it easy. Thanks for that, Big Dog. Okay, let's continue on to the next page here. Okay, explain why diluting the battery acid increased the pH by 1. Okay, let me actually get that where you can see it. Hold on. Why diluting the battery acid increased the pH by 1? Excuse me. It's kind of what I was just saying right there. When we increased that volume of liquid without changing how much H3O is in there, we decreased the concentration to about 1/10 of what it was before. Okay, so in however you want to explain that, I'm just going to put we decrease the concentration to 1/10 of what it was. And I might put in something here about how the pH scale reflects times 10 changes. Okay, not sure really how else to put that. Okay, now from this point forward, you're going to kind of keep doing the same thing. So I'm going to get you started on this next part, and then I'm going to take a look down through the rest of the lab and see if there's any other curveballs. But what it's going to have you do from this point forward is it's going to have you continue doing what we did last time. We're going to have to drain this until we've only got 0.1 liters, and then we're going to add water to it to bring it back up to 1 liter. So back on our lab, I'm going to come to my drain plug. I'm going to take this down to 0.1. Now, taking it down to 0.1 doesn't change my concentration of hydronium because all I'm doing is reducing the amount of acid. I'm not changing the concentration of the stuff dissolved in there. Let me slow it down a little bit. You got to be really careful because if you don't, you have to start this whole thing over again. So I'm down to 0.1 liters. Now I'm going to add water to bring it back up to 1 liter. Now, watch for changes in the pH and watch for changes in my hydronium. Okay, look how the pH is increasing, becoming more basic. Look how this is decreasing and how my hydroxide is increasing. So it's becoming slightly more basic than it was. It's still very much an acid. Sir. And, oh, so close. Ah, dang it. Too much. We're going to go with that because it's close enough rather than have me start completely over. I'm just going to chalk this up to human error. Our numbers are still going to be just fine. So before we go back to the paper, let's see what's changed here. Our hydronium concentration is 1 times 10 to the minus 3. Our pH is awfully close to 3. So again, same kind of thing as last time has happened. So let's look at this. After, again, increasing the volume, what's the new concentration of H3O ions? New concentration, according to the other page, was 1 times 10 to the negative 3. And if I want to show that as a decimal, that would be 0.001 moles per liter. What's the pH of the new solution? I think we said it was 2.98. Let me double check that. Yep. 2.98, which again is awfully close to 3, I'm thinking in my head. And you're going to continue doing this however many times it tells you to do this. And each time, you're going to drain it. You're going to add water to bring it up to 1 liter. You're going to take the new concentration and the new pH. I'm going to go ahead and skip forward a couple pages and see if there's anything that might prove troublesome for you guys. Let's see here. Okay. On the very last page. Now, once you get to number 18, that's an interesting question. Okay. And I don't want to spoil it for you, but especially as you're getting close to number 18, I want you to watch very carefully what's happening to your lab setup. Okay, so as you're diluting and adding your water, go very, very slowly and watch what's happening in that very last step. Okay, this one, you really have to kind of think about it. Give you one of those dreaded hashtags there. And then for part Q and numbers 19 and 20, you're going to make a custom solution. So for that very last part, you're going to come over here where it says My Solution, and then it will let you play with these different concentrations and come up with some general rules of thumb for this last part here. Okay? But from this point forward, I think that I'm going to leave it to you to discover what happens. So let me unmute the crowd real quick and see if anybody has any questions.
I didn't get the rest of the question 8.
Rest of the question 8. Okay, let me put that back up right quick. Oh, quit. Okay. How's that?
Thank you.
You're welcome. Okay. Anybody else have any questions while we're here?
How do I do the moles over liters sign? Can I just use a backslash?
Yeah. So like moles over liters. Now remember, moles over liters is the same thing as big M. So you could just do big M again. You could also, on your thing, you could go MOL/L, like that.
Okay.
Okay.
And I think that was it.
Okay.
Oh, no, number 2.
Number 2. Okay.
one.
Hmm. All right. Does anybody else have any questions while we're here?
I have to do that on a daily basis, bro.
Daily basis on daily papers, as everybody's saying it.
Hmm. You know, as much as I miss everyone's face in person, hearing people like, I don't know, loudly blow their nose, you know, on camera, it makes me happy about this whole social distancing thing. I'm not going to lie to you. It's very juicy. Anybody else while we're here? Okay. Well, I've been talking for touch under half an hour, so I think I'm going to go ahead and end this. As always, if you have any questions, feel free to type them up in Google Class or shoot me an email or shoot me a private comment on the assignment itself. I'm going to be sending out an email later today and also posting on the class the assignments that I definitely want you to have done and back to me by Friday so I can get you some grades for them. This Friday is the end of the 6 weeks, and I have to have grades turned in by first thing Monday morning. So,
Do you know what our grades are?
I do know what your grades are.
Can I know what my grade is?
Can I know what your grade is? I'm not going to tell you about it in open chat like this. No.
Okay.
I'll be happy to shoot you an email later.
Okay.
Do you not have Darius? Do you not have Parent Portal hooked up?
I don't. My parents do.
Okay. Well, I mean, ask them.
Okay.
I'm pretty sure you're passing.
I was trying to figure out so that they didn't have a heart attack if I was under 85 or whatever.
I think you're doing fine. I think you're doing fine. And something I'm going to do for everybody's grades this time around. I know that there were some folks that had like baseball tournaments and stuff like that, and so they missed some work before before the break went into effect. After I get all my grades in, I'm going to tell the grade book to drop everybody's lowest daily grade and everybody's lowest lab grade, which should help everybody's averages out. And so that kind of, will account for the folks who miss something that they really can't make up, or folks who maybe miss something this week because they didn't tune in for whatever reason, because they couldn't get internet underneath the rock that they, spend their time on. I don't know. But anyway, let me worry about that later, and I'll be in communication with you guys as far as that goes. There's nothing else. Y'all have a very pleasant rest of your morning, and I'll catch you later.
All right. See you later, Mr. King.
Bye.
All right. Yeah.
Let's see here.